Welcome to the 4th episode of the Ada Lovelace Day podcast. My name is Sue Charman Anderson, and every month I talk to women from around the STEM world about their work, as well as talking to women and men about historic and modern women's achievements, discoveries and inventions. This podcast is made possible thanks to the generous support of ARM, our exclusive semiconductor industry sponsor. You can find out more about ARM's energy-efficient microprocessor technology on their website at arm.com, and you can follow them on Twitter at @ARMHoldings. If you'd like to join ARM as a co-sponsor of our podcast, then please email me at suw@findingada.com. This month, we start by going into space with Abbie Hutty, the lead spacecraft structures engineer for the ExoMars Rover Project. She'll be talking about how the rover is going to search for life on Mars, and the challenges involved in sending an autonomous robot to another planet. We're also talking to the founder of STEMette Anne-Marie Imafidon about the work of entrepreneur and computer programmer Dame Stephanie Shirley, who in 1962 founded the groundbreaking software company Freelance Programmers. So I'm here with Abbie Hutty, who's the lead spacecraft structures engineer for the ExoMars Rover Project at Airbus Defence and Space. Hi Abbie.
Hi, how are you?
I'm very well, thank you. Great to have you on the show. My first question for you is, I know what a Mars rover is. Can you tell me what an ExoMars rover is?
Okay, so ExoMars is the European Space Agency's first rover mission to Mars. It's called ExoMars because it's an exobiology mission. We're looking for life on another planet.
So the exo bit is about life?
Yeah.
So can you briefly tell me what a lead spacecraft structures engineer does?
It depends on the day, really. Basically, I'm leading a team of specialists who are trying to develop the structure of the rover, the body of the rover, the chassis of the vehicle, as it were, into something that can actually be manufactured and will survive all of the feats of endurance that the body of a Mars rover has to endure.
Which is quite a lot, I should imagine, because it's got to get from here to Mars, and then it's got to land, and then it's got to go around and actually search for life.
Yeah, so there's many and varied challenges. We've got a lot of materials challenges. The thermal environment on Mars is very unusual compared to terrestrial engineering applications. We've got all of the kind of launch vibrations and dynamic load cases, and then driving around on the actual surface of Mars and kind of dropping off rocks and that kind of thing. So all of the loading that you get when you're there as well.
So I presume that when the rover is on Mars, you're going to be digging into the soil at some point for samples?
Yeah, one of the big things that the ExoMars mission has that we've not previously had on any Mars rover missions is we've got a great big drill on the front. So that's pretty exciting for a number of reasons, but primarily we can take samples from well underneath the surface. So the drill can actually drill down up to 2 meters below the surface. And that's where you're going to be protected from the radiation environment at the surface. You can get down below the oxidizing radiation, the chemicals that you get at the surface of Mars that would break down life and organisms so that we couldn't recognize them. And that's where we think that life could still be kind of harbored if it's still there.
That sounds like an awfully deep bit of digging to do with a rover.
Yeah, it's a bit like a pile driving machine. The actual drill bits aren't 2 meters long because otherwise we couldn't take them with us. So it's individual little bits that pile down into the surface, and then another one slots into the top of it and drives that further down, and then another one slots in, that kind of thing. It's quite neat, really.
Yeah, it sounds it. So I hate to ask this question, but what happens if it gets stuck?
We do actually have a jettison capability. We have thought about this, just because you don't want to get tethered to a single place on the planet. But we have ground penetrating radar on our rover as well, another nifty piece of kit. So you can actually scan where you're going to drill before you drill and make sure that there's nothing that's too hard or too dense to drill into that you might get stuck on. So hopefully that won't be an issue.
So one of the things that I got interested in when I did my degree, which was geology, was the remote operated vehicles, like these little labs that you throw over the side of a ship. And there's a lot of lateral thinking that goes into that. Is that an important part of your job, trying to put these puzzle pieces together in a way that will make sure you don't get stuck in one spot?
There's definitely a lot of things that you have to think about in terms of redundancy, because you can't go there and fix it. You can't send another one very simply. It's a basically all or nothing type mission. So you've got to make sure that if any one thing breaks, it doesn't completely kill the mission and you can still do useful science in other ways. So all of our drive motors, if one of our wheels stops turning, we've got to have enough torque in the rest to keep going. If one of our solar array cells stops working, we've got to make sure that it's not going to take out a whole panel with it and that kind of thing.
So it's really this giant 3D jigsaw puzzle where every bit has to be expendable almost.
As much as possible, yeah. I mean, obviously there are certain things that you can't do a great deal without. But a lot of things you can make sure that you're wired up in parallel rather than in series so that you can still have some functionality, just a decreased percentage functionality if a certain component fails or breaks on the surface.
What is it that gets you the most excited about your work?
There's lots of little things. I just love writing Martian legitimately in technical reports. That will never get old. Just one of the little joys of life is to write about the Martian environment or Martian dust or when on the Martian surface. I love it. I do like a bit of whimsy in my life, so things like that tickle me. But I just do love going down to our clean rooms and seeing the actual hardware being built and knowing that something that I've kind of dreamed up and my team has developed over the years. So once upon a time, it was just a kind of figment of my imagination or a concept that we were throwing around and chatting about. And now it's being made, and then it's going on a rocket, and it's going to Mars, and it's going to touch Mars where no human has ever been before. It's going to leave prints in the sand, and they're going to be the shape that they are because that's what we made them. And I just find that mind-blowing, really. Humbling.
That is absolutely amazingly mind-blowing. I remember I used to read a lot of sci-fi as a kid, and I remember the precise moment that I realised there wasn't actually a moon base and how deeply disappointing that was. And when you think about actually sending something to another planet, you know, it's going to be there, it's going to communicate with us, it's going to send us all this amazing information. It's just mind-blowing completely.
Yeah.
I'm just trying to get a sense of the way that your job works. You know, you do the design work and you figure out how to solve a particular problem, and then you work with a different team that actually builds and tests it. So how does that all slot together?
I do a lot of talking to people. Definitely. It's a very social job that I have. So I'm leading the team who basically inherit the concept design from the team that built up the overall scope for the project. So we got this kind of vague concept design and size and shape and approximate dimensions from the initial team, and we have to develop that into something that works for absolutely all of the requirements. So we get a list, a specification of all of the things that it has to be able to do, and all of the interfaces that we have to provide, and all of the temperatures we're going to have to survive, and all of the radiation, and all of those kind of things. And we just have to develop the structure to make sure that it meets all of those requirements, and do all of the materials development and testing, and all of the manufacture tests to make sure that it really is going to survive that, and prove to our customer, the European Space Agency, that it does meet all of those requirements and it is a final, complete, compliant design. And then we build it. Or we don't personally build it. We use manufacturing subcontractors to build it, make sure that it's all meeting all of the requirements, and then send it off so that everyone else can integrate all of their other equipment into the structure.
Wow, that sounds quite daunting to the layperson, to me. It feels a bit like, gosh, where do you start? It must take a lot of bouncing ideas around and lateral thinking to do this kind of stuff. So what kind of qualities do you think you bring to your work that are important to being able to do this?
That's a difficult one. You've definitely got to be quite analytical and logical and just be able to break things down into manageable chunks. So, yes, it's a daunting concept to start with, but actually if you can kind of break it down and say, okay, well, we know that probably we're going to make it out of this kind of material because of this reason. So let's look into these materials. And okay, well, we know that it's got to be roughly this big, so we're going to have to make it in this way. And okay, we're going to have to make it roughly to fit into this mass, so we're going to have to use this kind of construction technique. And you kind of break it down into manageable bits. And then you've got to be a bit creative sometimes, because sometimes it doesn't point to an immediate solution. So you've got to be able to think outside the box a little bit and just come up with lots of wacky ideas sometimes. Be a little bit brave and ambitious with your ideas, and every now and then one of them will actually slot into place, and then you can tick another thing off.
This all sounds quite complicated. What kind of challenges do you face with your work? Because this does not sound like a simple day at the office.
Well, there's no such thing as a simple day at the office, I have to admit. It's always a challenge. There's always things that suddenly materialise that you thought your solution would solve and meet requirements for, and then you do some testing and you find out that actually no, it's a mile away from meeting that requirement, and you're going to have to come up with a whole new solution. And because you've got a complicated system and everything kind of meshes together, if you change one thing, the impacts can be quite far-reaching. So you have to be very creative to come up with solutions that don't increase the mass, which would then increase the power that you need to drive your rover around. That means that you need bigger solar panels. That means that you increase the mass of your solar panels. And it just kind of snowballs. So yeah, we've got some very constraining requirements and a very tight kind of space in which we can actually operate. And so it's always really challenging to meet your requirements, which are not kind of normal things that you come across every day and you know how to do, whilst staying within this zone that you can operate in. It can be pretty tricky.
It does sound like the kind of job where you will come out having learned an awful lot more than you knew when you went in.
Definitely. I know all about the dust on Mars and the speed of winds on Mars and the abrasion rates of the hardness of the sand on Mars. That's what I've been looking at this week. Stuff that you never even dreamt of thinking of that you might want to know, let alone needing to know for your job. But it's quite interesting.
I'm betting that wasn't in your degree.
No, funnily enough, I must have skipped that module.
And is the dust on Mars particularly different to Earth dust?
Well, there's a lot of different types of dust on Mars, but the stuff that becomes airborne is quite fine. It's almost like talcum powder. It kind of sticks to things, clings with static, and gets everywhere, and is a bit of a pain, really, actually.
You talk a lot about you're doing this sort of conceptualization and testing of ideas and trying to come up with a plan that then other people go away and build. I mean, this sounds like a very collaborative role. This isn't just sort of you sitting down with a sort of drafting board and pencil and figuring it all out.
Oh, no, far from it, no. No, I've got a team. Over the years that we've worked on the project, it's kind of fluctuated between maybe half a dozen and 15 people, and everyone has their specialism. So there's people who are 3D designers, materials specialists, stress analysts and dynamicists, and they all have a particular role in terms of developing the design. So we collectively come together and look at a particular element that we need a new or modified solution for, and brainstorm some ideas, come up with what's probably the most sensible approach, and then each person will go away, and so the materials specialists will look into the materials and how we can make that work and how we can manufacture it, and the stress analysis will look at the strength of it and whether it meets the requirements and that kind of thing. And then we all kind of come back together, compare our notes and make the tweaks that we need to make the thing work. And then if we need to, we go around that kind of iteration loop again. So it's definitely a team effort, and that's just for the structure. And then we've got to feed our structure design into the overall system design, and they've got to make sure that that then works in conjunction with all of the other elements of the rover, so all of the onboard equipment and the drive mechanisms and that kind of thing. And then the whole thing then feeds into the overall mission, so the rocket, whether the rocket has enough power to lift it, and whether the cruise module has the right amount of fuel on board to take it across from Earth orbit to Mars orbit, and all of this kind of thing. So there are literally hundreds of people around the world all working together on their various elements that all feed into this big machine to finally get the whole thing to Mars.
So what's your favourite bit of the Mars rover?
Again, just on a whimsical point of view, I love the fact that it's got a little head with eyes on it, because you can't help but personify the thing. So it is going to be a character driving around on Mars. It's not just a faceless robot. It's not a faceless robot. It's got a face, basically. And I love that. But for scientific reasons, it's not because we just want to make it cute and cuddly. It needs two eyes so that it can see in stereo. It's got two cameras, and it needs a box that houses those cameras, which is a head. And we actually have to have that head kind of on a neck, on a mast, so that the camera images that come back are kind of recognizable to geologists, and so that we can actually see over rocks and craters and things like that. So there's a reason for everything, but I just love the fact that science makes it look like a character.
I was just going to say, it looks a bit like Wall-E, or possibly, was it Johnny 5?
Yeah, definitely. Showing our age there, but yeah, definitely.
I wonder how many of the character design folks in Hollywood are looking at the sort of ExoMars rover and going, yep, we got it right.
I hope so.
Excellent. So what are you looking forward to most? What's coming up for you that gets you excited?
At the moment, we're beginning the manufacture for all of the test models, but as soon as they're done, we get to go and sort of bolt the whole thing together and do some really intense structural and thermal testing. That'll be pretty exciting. That's the first time that everything really comes together and looks like the final design. And we take it out to see these massive vibration chambers and thermal chambers, and we make it very cold and very hot and cycle it up and down like it'll see on Mars, and do lots of vibration testing and acoustic testing and that shock testing and things like that, and really kind of give it a hard time. So that's when you start to see that, yeah, your design does work. It survives all of these things, and it looks like a Mars rover and that kind of thing. So that's all pretty exciting.
Wow. And so what kind of temperature is it going to have to deal with?
Well, on Mars it's very, very cold. So we've got to be able to cycle down to minus 130 degrees centigrade at night. So that's really very cold. Yeah, very, very cold. And we actually might have to drive around even during the Martian day at kind of minus 75 degrees centigrade, that kind of thing. So that's way colder than even kind of military grade Antarctic survival equipment has to operate at. So that's quite a challenge. But then on the flip side, because there's not very much atmosphere on Mars, there's basically no wind to cool you down. So if you're exposed to the sunlight, various parts of the structure can actually get pretty hot, so up to about 75 or 85 degrees centigrade in the sunlight. So that's, hot enough to fry an egg on. So you've got this whole spectrum of temperature that you've got to be able to survive. And then to make matters worse, because we're looking for life on Mars, we've got sterilization requirements that mean that we're not allowed to take life with us to Mars. We've got to be able to sterilise all of our kit before it goes. So we have to bake everything out in a big oven at about 130 degrees centigrade before it goes to sterilise it. So we've got this full sort of minus 130 degrees to plus 130 degrees that everything's got to be able to survive, which is just huge.
Wow, that does make the freeze-thaw cycle here in Wisconsin look a little tame in comparison.
Yeah, it's pretty extreme, really, our rover. It's going to be a hardy little soul.
What's the sort of timeline? Do you have like a launch date set yet, or?
Yeah, so the launch date is 2018. It's due to launch in the summer of 2018, and that's because of the planet alignment. So Mars and the Earth kind of align in an optimal way for getting from one to the other about every 26 months. So 2018 is our next opportunity, and then it takes about 6 months to get there if you launch in that window. So then we'd arrive to the surface in January of 2019.
And so will you be taking that 6 months off as holiday?
I wish. No, I'm sure I'll find lots of things to occupy me in the meantime, but those are definitely days that I'll be quite preoccupied. The launch and the landing, fairly fundamental ones. I'll be the one hiding behind the sofa, probably. Jumping up and down in the control centre, punching the air or something like that, with any luck.
Excellent. Well, I can't wait to watch the launch online. I'm sure that the European Space Agency will be streaming it. Everything gets streamed these days.
Absolutely, yeah.
And I think it's a fantastically exciting project that you're working on. Thank you very much for spending some time with us and telling us a little bit about what it's like being a lead spacecraft structures engineer. I now know a lot more than I did when we started talking.
Well, thank you for having me. It's been great fun.
And for those of you who want to know a little bit more about the ExoMars rover, Abbie was one of our speakers at Ada Lovelace Day Live 2015, and you can see the video of her talk online on our website, and the links to that will be in the show notes. Thank you very much, Abbie, and we'll talk to you again.
Thank you very much. Bye-bye for now.
So I'd like to welcome to the show this month Anne-Marie Imafidon, CEO and head STEMette at STEMette. Hi, Anne-Marie.
Hi, Sue.
Now, you want to talk to us this month about a woman who is a big role model for you, someone that you admire a huge amount. Who is that?
Well, that is Dame Stephanie Steve Shirley, who was a big tech pioneer back in the 60s, and I think she's incredible.
And Dame Steve Shirley, because people call her Steve, and there's a particular reason why she's known as Steve Shirley, isn't there?
There is. So when she was doing business back in the 60s, you know, as this tech CEO of this development company software house, with her born name of Stephanie, she found that it was tougher for her to get meetings and you know, to set up contracts. So she shortened it to Steve in order to kind of get her foot in the door. In certain meetings and with certain clients, and found that, you know, once she got her one foot in the door, you know, they couldn't turn her away, and so she'd win business that way. And yeah, that's how Stephanie became Steve, and still is Steve to this day.
So one of the challenges that Steve had was not just that she was a woman in a man's world, but also that she'd started a software company at a time when you got the software with the hardware, which, I mean, seems a bit strange now, but that was how it was done back then. But she really changed how we think about software.
Yeah, absolutely. And I think it's one of those things where I don't even think it was intentional per se, but it was just the nature of what they were doing and how things worked. For it to be distributed, you know, hardware couldn't really be a part of their offering and their stack and what they were doing. But yeah, no, definitely how software can be written, that kind of distributed modular way of doing it was definitely, you know, quite a tough thing, I think, for her to convince people of. But it's incredible to think she was doing that in the 60s, way before we had all the advances that we've got now.
And again, something else that's kind of amazing was it wasn't a company the way that we think of companies, was it? I mean, a lot of her staff, all her staff were women and worked from home.
Yeah, and they also all had shares, so it was a social enterprise as well. So it was not just for profit, but, you know, for the benefits of the people that were working within it, almost like the kind of Waitrose John Lewis partnership setup. But yeah, she did do that with these women who, back then, if you were, even though you might have been a qualified mathematician, as many of them were, you know, once you had children, that was your lot, that was your life. You worked at home and were a full-time mother. So it was incredible for her to say, actually, you know, we're going to use this spare capacity, give them something to do, give them real projects, have them working on real corporate projects, platforms, systems, software, and have them doing that. And, you know, things like the black box for Concorde were programmed by these women, which is, you know, now it's insane to think that we don't hear more of her or don't know more of these women.
Yes, and how they did the work, because again, you know, we have modern ideas of what programming is, but they were not sitting in front of a computer working in terminal. No. That's not how it worked.
They were on kitchen tables. They were on kitchen tables with, I guess, pen and pencil and punch cards. Again, incredible. They couldn't email it in. I think it was often posted. It's one of those things that you almost have to see in a film to understand it, and even then you still won't believe it.
Because, again, you know, they weren't programming in a language.
No, it was low level. Yeah, it was low because of the time as well. It was very low level programming, and it was algorithms as well, right? So they in addition to things like Concorde, they also did a lot of the algorithms and calculations around things like train timetables and bus timetables. So it was, you know, really early on things that, you know, when you think of what we're able to build today, this is like the early days of computers and what they're able to create and build and calculate.
We forget, I think, how complicated a lot of these tasks really were. And my granddad worked on the railways and was a timetabler, and everything was done by hand. It's mind-boggling to think about how complex that was. And they took that level of complexity, and without actually access to a computer on your kitchen table, they coded a way to organise all that data.
Yeah, they did. Incredibly complex, and I think that's the beauty and the excitement and the unbelievable factor of it all was, like you're saying, they were doing quite low level resources, and in a way that hadn't really been done before, and which, you know, if you're thinking about it simplistically, should actually make things more complicated. But it didn't. It worked. You know, it's models that we now use today and take for granted today.
She created 70 millionaires when her business floated on the stock market.
The return on investment, the proof was in the pudding.
Absolutely. And yeah, you know, it, as you say, you know, she should be a lot more widely known. And I think if that happened today, you know, 70 millionaires today from a public offering would be massive news. And to think about what that was like, that was 96, I think.
I think the thing that saddens me about all of it, though, is that it was close enough to today. So I think it's almost forgivable if, you know, between Stephanie and Ada Lovelace, for example, it's almost forgivable if we forget people if they're not living anymore. I think the greatest travesty has been that she's very, very much alive and kicking, is, you know, a completely unsung hero up until today. So I think, you know, for me, looking back, I'm almost quite annoyed and irritated. I remember I was furious, actually, first time I heard about her, because I thought, you know, there's so many other people that are in the public sphere, so many other people that we credit are in curriculums. Why isn't she a better known name? Why isn't she a more public figure? Why isn't she someone that we talk about? You know, and she's still here, she's still alive. You know, we should have festivals, processions, all sorts in her honour, in her name, especially given, you know, where technology now is and the role that she played in all of that. You know, even if we don't talk about the money and the millionaires, I mean, the millionaires even more so is the next level of why, you know, she should be our Oprah, and she's still alive, she's still here with us. Do we have to wait for someone to no longer be alive for us to appreciate them? That's still my anger now, actually. It's still my frustration. You know, when I talk about, I have this quite a lot with parts of history. I remember, so I was born just as the Berlin Wall was coming down. And I remember it wasn't until my 20s, because I didn't really study history at school, that I realised the circumstances under which the Berlin Wall went up. And for me, the 60s has always been something that's been sold as, you know, Twiggy and short skirts and, you know, great times. And it was like, but all of this was happening not too far away. And I think for me, she's another example where, you know, if I'm asked these days, who were my role models growing up, because I do a lot of work with role models and female role models and women in STEM and in tech. I think, you know, when I was growing up, all I knew was Tim Berners-Lee. That's pretty much the only tech person that I knew of, you know, as I was doing all of what I was doing and as I was exploring tech. And for me, it's frustrating. You know, if I'd have known about her, the world would probably have been different.
I had an aptitude for programming when I was sort of like 9 or 10. And if I'd known that this was something that women did, if I'd had any encouragement, you know, who knows what would have happened. But
exactly.
I think as well, you know, you mentioned the Berlin Wall, and actually Steve Shirley's personal story, it's not just her business story, it's not just the sort of, you know, woman in computing making this amazingly successful business, it's also her personal story that's inspiring.
Exactly. So I mean, that's why I have anger. I think it rises from frustration to anger, because there's so much that she's had to battle about. Her story from, you know, being part of the Kindertransport and coming over from Vienna, not even growing up with her birth parents, you know, right through to her being a parent and all of that. There's so much there. You know, you couldn't make it up. A lot of her life is so remarkable. You literally could not make this up. If you made this into a movie, or a film, you could stay true to every single aspect and it still be an incredible story to watch. And why we haven't picked up on that as a nation, I really don't understand.
Even now, I mean, she does a lot of public speaking, and she has donated a vast amount of her wealth to causes like the Oxford Internet Institute, and her son had autism, so she's donated a lot to autism research. And she should be a name that's on everyone's lips.
She should. she should. That's why as many times as I'm asked, I'll always go to her. I think we're definitely I haven't run it by her yet, but we are going to, you know, eventually we're working towards setting up something in her honour, some sort of festival, some sort of big scale thing to kind of to recognise her really and say thank you for all that she's done and the inspiration that she has been and that she will continue to be for generations to come.
Yeah, which I think is an absolutely fantastic idea, because we do need to find these ways, you know, however we celebrate women in STEM. That's one of the nice things about Ada Lovelace Day, has been now a lot more people know who she was. And it's a major part of how we create our own narratives of the past, how we understand the past, is through the stories of people who played such a major part in shaping the world that we know today. And she did a lot, not just to work with women. So all of her employees were women up until the Equalities Act. But yeah, you know, she also pioneered remote working. You know, she pioneered how we think about software, how software is written, and that's an awful lot for, you know, one person to have that huge of an impact and yet still be essentially, you know, not hugely widely known.
It's insane. I can't say enough how much it infuriates me, and I think, you know, it like you said, it's our narrative as a nation and also within the world. And I think there are so many parts of our history that, you know, you'd think don't really deserve to be there almost. And there are other people that are so deserving, and I think she's one huge example that we have of a great that should definitely should be on everyone's lips. Should have a day in her honour.
Is there anything specific about her story that has inspired you? Any particular moments where, you know, you've been stuck or sort of in a difficult position and you know, you've got to thought, well, she can do it, I can do it.
So I don't know if there are any moments that I can point to. I guess when you run your own organisation, there are always ups and there are always downs. And I think for me, I always go, the part of her story that really gets me is, you know, given all that she did, it's the time in history that she did it. So, you know, I always talk about being a woman in technology and the fact that I didn't even realise I was a woman in tech up until, you know, I was in my early 20s. And I think it's one of those things that I didn't have that inhibition. I didn't feel like I had society saying anything negatively at all to me for being a woman or a woman in tech. Whereas if you look back at the 60s, the legislation, policies, just the way society worked, you know, she talks about having to have her husband sign so she can set up the bank account for her business. You know, all those kinds of small things that I have no conception. It's not even within my context or my awareness or anything that might be a barrier. So it's almost like, you know, if I walk through life, I walk on a level pavement, it's very flat, there's no potholes or anything in it, whereas, and you know, I'm just walking where she's been running, where there's potholes, where there's rats are going across the floor. You know, it's almost like, you know, if she was able to run that race, I'm chilling. I'm lying back, I'm on holiday, I'm not even bothering to get involved in the race. So, you know, if she, even if she did complain, if she's made it through and made all of that happen, what more? It's almost, you want to sit on the shoulders of giants, right? You want to progress, you're the next generation. What more am I doing, given the fact that I don't have all those hurdles put in the way? And so that's what it always is for me. You know, they say, you know, someone always has it worse than you. She had it worse than I will ever have, because I live in 2016. I can open a bank account if I want. I can buy a house without my father or my husband giving me consent to do. I can run a business without either of their consent either. So whatever problem I'm having, she had it 10 times worse, and she made it out the other end. So I'm gonna have to. So anytime anything is too tough, it's almost, we're gonna probably make mugs or whatever, but it's what would Steve do? And so, you know, guiding light of just think, you know, channel Steve Shirley and get on with it.
I like that. And you do a lot of really fantastic work encouraging girls into technology with the STEMettes. How much has Dame Steve's work kind of moulded how you try and transfer that enthusiasm and that confidence onto the girls you work with?
You know, we're definitely really vocal about her to them, and we do share her story, and we're fortunate enough to have a relationship with her where she has created resources for us or been a part of our interactions and interventions before. And I think, I can't say this enough, the story she has, if you hear it and you see her, it's so real and so raw that you can't possibly interact with any part of that and not feel like you can do anything. Like it's one of those stories, she's one of those characters that is very, you know, very British as well, in that whole thing of, you know, she says it herself, you know, it's 2016, you've got it easy. So it's almost that thing of, hey girls, you know, it's almost, you know, get over yourselves, get over the internal anguish that you might have with some of this, of being different or trying something different and all of that. I did it. This is 2016. This is it. The world is your oyster. It's your choice whether you're doing it or not. Don't let anything else inhibit you. So I definitely think that that kind of spirit of Shirley, definitely lives on in the way that we interact with the girls. And I think for us as an organisation, it continues to motivate us. And it's, you know, like I'm saying, you know, it's not just me at the head of the organisation, but if we're running anything, it's, you know, what would Steve have done? Like, we can handle this. She handled worse.
Absolutely. Just to round out, what's coming up for STEMettes in the future? What's on your calendar right now?
So we have a number of things coming up. We filmed a documentary. So we ran a big summer project last year where we had 115 girls from across 5 different countries, living 45 at a time under one roof over a period of 6 weeks in South London, learning about startups and running their businesses and product development and agile techniques and all sorts of great things to do kind of across STEM, which Steve was a part of and kindly recorded a video session for us. And we actually filmed a documentary of that experience and of some of those girls and some of their stories, and almost a kind of, you know, where they were before the project, them during their time in the house, and then where they are next. So that's a documentary that'll be ready in September that we'll be putting out. And for us, it's nice to add a British voice to that girls in tech narrative, but also to kind of show, you know, the scale of the problem, but also the scale of the opportunity. So we work with a lot of girls from different backgrounds, and for us it's nice to be able to show kind of side by side those girls from different parts of the country, from different backgrounds, of different ethnicities, all coming together and you know, learning and working and being inspired by each other. We also are working on a couple other sort of media projects alongside the work that we're doing. So we, you know, run our events, run our workshops, run our interactions with girls all over the UK, and so ramping up those, but also seeing, you know, how do we allow girls to pass it forward. So there's a lot of work on, a lot of talk about role models and women in industry. And I think we also have really inspirational girls and young women in the country. And how do we empower them to, you know, bring others into the fold, include more people, in addition to kind of exposing us to the more obvious set of role models who are the women there in industry. So there's a lot there, and there's a TV script as well being written, which I'll just leave as a teaser.
That's really exciting. I'm looking forward to seeing the film when it comes out. Thank you so much for talking to us this month, Anne-Marie.
Thanks for having me, Sue.
And you can find out a lot more about STEMette. We've got links in the show notes as ever, and I strongly advise you to check out their work. They're a fantastic organisation doing really great stuff. Thanks to our guests this month, Abbie Hutty and Anne-Marie Imafidon. If you want to find out more about them, just visit our website at findingada.com/EP4. We've got video of Abbie's Ada Lovelace Day 2015 talk about the ExoMars Rover, where she explains more about the challenges of finding life in the hostile environment of the Red Planet. And we've got links to the STEMettes and video of Dame Stephanie Shirley's great TED Talk from last year. Also on our website are details of Ada Lovelace Day Live, our fantastic science cabaret held this year at the IET in London on the evening of the 11th of October. We have an amazing lineup of speakers, including design engineer Yawandi Akinola, planetary physicist Dr. Sheila Kanani, mathematician Dr. Sarah Santos, and computational biologist Dr. Bisan Al-Lazikani. Tickets are on sale now at the early bird rate of £10 until the end of August, and you can find the link to our Eventbrite page in the show notes. You can also find out about all our speakers and watch talks from the last 3 Ada Lovelace Day live events. Just visit us at findingada.com/EP4. Thanks again to our sponsor, ARM, for their ongoing support. If you'd like to join them as a podcast sponsor, please do get in touch. Thanks also to our editor, Andrew Marks. You can subscribe to our podcast on iTunes, Google Play, and Stitcher. And you can follow us on Twitter at @FindingAda. Links, again, are in the show notes. If you'd like to send us feedback about the show, or if you'd like to take part, you can email me at sue@findingada.com. Join us next month when we'll be talking to structural engineer Roma Agrawal about her work on the Shard in London and the challenges of retrofitting a Victorian building. We'll also hear from biological psychologist Dr. Peter Etchells about fellow psychologist Dr. Suzanne Gage, who's investigating the relationships between health behaviours and mental health. So we'll see you next month.